Flat Earth researchers, debaters and debunkers. I'm going to turn this around. Just a second. There we go. Okay. Here we are at Portishead Pier. Nice bit of sun. Just had some hail actually. And good opportune moment to talk about the tides and the connection with the moon. I was just down there on the beach chatting with a fisherman, and we got talking about the differences in the fish that you can catch at different tide times, and of course the tide's relationship with the moon. Hi, sleeping warrior. Yes, I'm going to make a claim. Yeah, I'm just going to repeat what is already a fact, and then we can think about that, yeah, and how it relates to our physical reality. So of course, you know, we've got this notion that the moon causes tides because of its gravity, which is ridiculous, as I discussed in a video just now. But what happens, of course, is that yes, the only correlation you get with, hi Tony Dixon, with the moon and the tides is not this daily occurrence of tides. Here there are at least 3 approaching 4 tides per day in a 24-hour period, and of course the moon only ever goes overhead once a day. Ingested red, hi. So, you know, on a daily basis, the moon doesn't do anything to the tides. It's not this magical gravitational pull of a rock up there based on the globe Earth model that's pulling the tides. There's nothing to actually prove or measure that that's what actually happens. It doesn't happen to anything else either. Anyway, besides the point. So the only correlation or coincidence that you get when with the moon and the tides is the difference in the tides during a full moon and a new moon. That's when you see the most significant rises and falls in tide levels. And so what we have is also a difference in air pressure. The air pressure correlates with the tide. So high and low tides depend on, or the extent of a high and low tide relates to or correlates with a difference in air pressure. Yeah. So if you take a container, we know that a difference in pressure in the container can make a difference to the water level, or you're putting, of course, things on this large scale are getting pushed around by the difference in air pressure. So of course, also related to air pressure is temperature. So yeah, fluctuations in temperature will bring about a change in pressure, and we know this is scientific fact that they have a relationship there. Again, it can only ever be done inside a container. Otherwise you've got no way for pressure to build up, or so if we take the analogy of a can, a spray can or something that has liquid in it, and then you let that pressure come out, then you've got a change in the temperature, haven't you? Things get cooler. There's less pressure inside the container, and fridges work on the same principle. Yeah. So temperature and pressure are intrinsically related, and they of course are also in line with the difference in the tides on a monthly basis. So what about the moon? It's like a clock, isn't it? The hands of a clock can tell us the time, but that doesn't, the hands on the clock don't make anything happen. They are not a cause. Yeah. But of course, if we see it's night, we're late for an appointment, then that causes us to do something about it. But the clock itself is not causing anything to happen. It is just a measurement, a way for us to look and record and predict the time. And that's the thing with this whole model, or any model that you might want to produce, the model that anyone works off, regardless of how they want to illustrate it, is these kinds of differences that we can measure. The difference in pressure, the difference in temperature, the difference in day or night. These are all ways that we can measure and then predict things, because we've got clocks, or we use the moon and the sun essentially as clocks, and they are like different parts of the clock. So the way I see it is they work in tandem. You know, the sun and the moon are working together, and they're doing different things. Of course, the sun, as we all know, heats things up, and when you get a change in temperature, you get a change in pressure. Sun comes overhead once a day, there it is. And then of course it's followed by the moon, or sometimes is preceded by the moon, depending on the phase. Many of us, including myself, have measured that there is a difference in temperature, a cooling effect from the moon. And of course, whether the moon is full or waning or waxing or new might make a difference. In fact, I've done the control test myself with the moon temperature tests, tried various ways to make sure that the thermometers weren't getting affected by any wind or what have you. And when there is a moon, a full moon, there definitely is a difference between moon shade and moonlight. Moonlight is cooler. It cools quicker. You can cool things down quicker with it, like a glass of water. And then on a new moon, you don't get this difference in temperature when you've got something that would be in shade, but of course there is no moonlight. So you end up with two thermometers measuring the same temperature. Whereas if you put a thermometer in moonlight and another thermometer, or in water in moonlight, put a thermometer in warm water, hot water if you like, 2 glasses of hot water, one that you're going to put in the moon shade and one that you're going to put in the moonlight. Put your thermometers in, and you see which one cools quicker. And of course you can make some safeguards to stop drafts and things like that, but the water bathed in moonlight will cool quicker than the water in the shade. So again, this is something that many of us have tested, and it appears to have an effect. And of course, this is only on ever small bodies of water, but again, it's something that is scalable. So what am I saying there is that as far as explaining and describing the causes and effects of the tides in something that relates to real life physics, then what we have is changes in air pressure and temperature going on all over the place all day, because obviously the sun, as it comes over, makes a difference in the temperature of the air, and then of course that's going to change the air pressure. And you've got all these pressure changes and temperature changes going on in this kind of flow, in waves, if you like. And then, of course, we get these waves of tides, because the pressure or the wind is pushing the water. So that in itself makes sense if you make, of course, a few assumptions, as is done with any model of which we do not know the actual parameters. Then this all makes sense in some kind of container. And gravity, as is described in the globe model, doesn't work on air pressure. You see, gravity doesn't make a difference to air pressure. It has no effect. That's one thing I went through myself a long time ago when I first started thinking about this, because you think about all the things that are affected by gravity, and a difference in air pressure or temperature has nothing to do with gravity whatsoever. But the differences in temperatures and air pressures in a container have everything to do with the environment in that container. So whether it's aerosol cans or fridges or some kind of enclosed environment like this, then that is a scientific explanation of what's actually happening when we see a difference in tides, and we know that there is a difference in the temperature depending on the sun and the moon. Yeah? And okay, I can see some people are saying something about it being electromagnetic. Well, heat and light everything is frequencies anyway. I mean, electromagnetism is just, I mean, this is a massive range of frequencies. So even the things we are seeing are a certain frequency, different frequencies of color, right? There is a small section on that band of the electromagnetic spectrum that gives us sound, color, vibration, all of that. Yeah. So yes, I mean electromagnetism, you can call it like that. And of course, yeah, you've got this again. All it is this fluctuation. I know FPV Angel has been talking about compression, and of course, yes, that's exactly how everything works. You've got this compression and decompression, this springiness, this inhaling, exhaling, just like any living organism. There's rhythm. Yeah, and again, it's that rhythm that has been used to make predictions and tell the time, and then from then, that's what you create any model from. But you're not doing anything new. You're not doing anything that hasn't already got a scientific explanation. Yeah, so that's my take on it. And let's have a look. I'm just going to start looking through the chat now, see if there are any comments. Thanks all for coming along. All right, ingested. Yeah, a bit better weather. Yes, thank you. AJB, electromagnetic interactions between the sun and the moon push and pull bodies of salt water. Yeah, again, it makes sense, doesn't it? I'm not saying there's only one explanation. Everything is interconnected, isn't it? I mean, that's what we see here. We can't just, and of course we're also faced with this notion that mathematicians have come up with an equation to summarize life, the universe, and everything, and of course that's what they're trying to do. They want a simple answer, and the thing is, you can make predictions about tides, but you can't predict exactly how high or low the tide will be, because there will be daily fluctuations in the temperature and the air pressure. So you can only predict when they will happen, but to come down to the fine details is not something, is always going to depend on circumstances or elements or factors that you can't factor in. Okay, Ricus Vaticus, there is no them and us. As far as I'm concerned, there are simply people who have come to realize the globe does not represent our truth. Yes, Ricus, yeah, yes, I would love to get away from this false dichotomy that's been created. And therefore need full exploration to find out where and what. Yeah, sure, full exploration would be very useful. If we could know, then that would maybe stop some of the other craziness that's going on in this so-called global world. Right, nothing wrong with theorizing about the tides. Oh, yeah, go ahead, man. Yeah. Someone trying to get past. What's that? Bomrathans. Why is there no scale on an FE map? Can you explain your lunar... Oh, gosh. Yeah, I can't be bothered. Sleeping Warrior, all maps are FE maps. Yeah, okay, yeah, that's right, Sleeping Warrior. Yeah, okay, as far as the, just a quick one on the azimuthal maps then. The thing is, if you're going to use an azimuthal map, then what you need to do is change the center of the azimuth to wherever you are at any given time. Yeah, all we have with the globe is two azimuthal maps stuck together. Yeah, because it's just an azimuth map from the assumed North Pole and the assumed South Pole. Suddenly you've given a sphere a top and a bottom, which is ridiculous anyway, because that is not something that happens with a sphere. It doesn't have a top or a bottom. That's all it is. The North and South Pole are just 2 points, 2 reference points for 2 different azimuthal maps, and they're put together as a sphere. Yeah, and of course, it's quite simple, but that's the thing. If the reason an azimuth map is the way it is simply because of the way our eyesight works. A small gap here ends up being a gap, further away. What you can see between my fingers is a lot more space on the horizontal. My finger, the width between my finger is about an inch or so, but that space over there in the distance on the horizon between my fingers, well, you can make it several miles. So of course what you've got is, on an azimuth map, you've got this these expanding lines from the center point that are not parallel. They're going out from each other because they represent the fact that you see more in a smaller space the farther you see. It's kind of, you got to imagine it like a mirror, but that's basically what an azimuth map reflects. It reflects perspective in the way that the angular size of something decreases in the distance. And so that's all an azimuth map is. So you've got to put the center wherever you are, and then everything around you is going to look as it should, and everything further away has to take up more space on the map because it's taking less space in your field of view. Yeah. So to use an azimuth projection from the North Pole to represent the flat Earth is not good either. I don't agree with that, because yes, I was distracted with the whole ice wall thing as well, the thing is, I think it's the other way around in many respects. I would say that Antarctica could well be at the center, and it is a continent. And then you've got all those other continents, South Africa, South America, Australia, around the edges, and you can have the sun and the moon going overhead in those places just as well. That's the thing. You can have exactly the same observations and predictions on an azimuth map of the Earth centered on the South Pole as you can on the North. So yes, the kind of North Pole azimuth projection for representing the flat Earth is misleading. And but for me it's been beneficial, because you end up going through it and trying to work out, and then you have to try and understand how maps are made and all that, and then it kind of starts to make sense. But it can throw you off at first. Anyway, let's go and have a look down at the chat. Hi Blood. All right, John. All right. Well, I really appreciate everyone coming along here. So, I've actually got a lot more to say on some videos coming up, which I'd like to share some thoughts with you about this whole thing. And I want to take a bit of a different direction with more to do with the how, the why, not the how. So this is the thing, we're talking about the how. How do you get a difference in tides? How does it relate to the moon? Well, again, we've just talked about it. Temperature differences, air pressure differences, tide differences, all in sync with the moon. So that, as far as that goes, that's an explanation, that's a description, that's a how. But the why, the why is a completely different thing. And I think that's where we are, that's of course where the globe gravity idea becomes, it has this, it's idolized like a god. Gravity becomes the god, because gravity is kind of appears to answer the why question, the how and the why at the same time. So that's why you eventually, when you think about this, that's why you eventually realize that the globe belief and faith in curvature and all that jazz is a religion, because it's God. The why of creation is passed off as being created by gravity. So gravity becomes a god. It appears to answer that question of how and why at the same time. Whereas what we're usually doing with scientific explanations is simply answering the how. We can, this car, we can describe how it moves along, yeah? And we can describe, and in very scientific terms, how it works, okay? But why? Why do we have a car? Well, that's different, isn't it? We have a car to get around. Why do we want to get around? Yeah. So because we want to explore, we want to have adventures, we want to do things, we want to go places. Okay, there are a whole bunch of different reasons why we would have a car. How it works is really not too difficult, and it can be explained scientifically. So when it comes to the sun, moon, and tides, then we've got a description of how it's happening. There's a temperature difference, there's an air pressure difference, and so there is a difference in the levels of the water. And we know that there is a temperature difference with how much moon can be seen. Yeah, so that's a how. Why the moon is there, why the Earth is here, why we are here, is beyond us. No one has the answer to that. So of course, with these so-called scientific explanations of gravity, you have this you kind of have an explanation for the how. I'm sorry, the why. Yeah, but it doesn't take you any further into how and why this place is here in the first place, why this even exists. And no one can answer the questions that go beyond that. There's still a limit to anyone's understanding. Where does anything end? We don't know. We simply don't know. So, yeah. But, so I want to talk more about the why in a few future streams or broadcasts. I think, to be honest, that's the question that anyone wants to answer. And of course, we're all seeking, and that's why it is such an exciting journey. For anyone, regardless of what you believe or how you perceive it, of course, that awe, that desire to know, that constant questioning, the why. And if you're still asking questions like a 5-year-old, then great, that's science. A child always asks why. You explain to them how something happens, and they accept it. But why? We're often faced with questions that we can't answer. Why this? Why that? And there's always a limit. You quickly, the child keeps on asking why, and you give an explanation, and you say how, and the child asks, but why? And then you give another explanation, and then but you always get to the point where there is no explanation because you cannot explain or know why. Yeah. So yes, I'd say gravity is the god of religion, Tony, and it is that force that creates everything in the globe mindset. Yeah, it's responsible, and again, so it's very disempowering, isn't it? This whole globe thing is very disempowering because you're suddenly being told that you are not responsible for everything that goes on this earth. It's all gravity, and gravity can't be persuaded. Gravity is a kind of non-entity which cannot be reasoned with. Yeah, so you cannot appeal to the authority that gravity is given as in its godlike status. So you end up feeling lost on this globe in this ridiculous spinning Spaceballs model. Insane. Absolutely insane. All because, and again, it all relates to telling time. The Gregorian calendar, the heliocentric model, the ability to tell time more accurately, that's been something. And it's funny because the churches have always been involved or leaders in clocks and timekeeping mechanisms. I think, I can't remember where it is, but the oldest functioning clock in some museum in the UK is from a church. Yeah? So, and these, you know, at the time, it was the churches. Well, when we could see that, they've all got clock towers on them, haven't they? So they were entrepreneurs. They were the forefathers of all this timekeeping and this fanaticism with it. And again, it's all very useful, but that's the thing, isn't it? Being able to make predictions gives one power as well, because then you have power and knowledge that others don't have if they haven't been looking. And that's the thing, isn't it? We're all looking, we're all thinking, and we're looking beyond what we've been taught to assume. And we're looking at reality versus fantasy. And we are realizing that there is a why, and the why is possibly very, very important to us, yet we have been disempowered. And so we are empowering ourselves again. We are taking our stolen minds back. And that's all this is. It's just empowerment of the individual. To be free of these beliefs and preconceptions and assumed authority over us. And the world will be a better place. All right. So I do thank you all for tuning in. And I will enjoy looking through the chat later on. So I hope this has been a nice little Sunday morning chit chat. And I wish you all a good day on this beautiful, level, stationary, possibly contained Earth. Have a good one. Cheers.